Hi, in this section, we are going to discuss about the introduction about the tree data structure and what is tree and what is binary tree and what is binary search tree. So along with this, we need to familiar with some terminology related to this tree data structure, and that will be usually or commonly used in the data structure of tree widely in while coding or while implementing the solutions. So let's familiar with those terminologies. Let's start it. Okay. So first of all, what is a tree? A tree is undirected acyclic graph where two vertices connected by only one path or one edge. In graph theory, this is the definition for the tree. So in the graph theory, the tree is defined as like it's undirected acyclic graph. Okay, and each will be connected by the only one path. Okay, there will be only one path. So on left hand side here, this is the a sample of tree. Okay, so this data structure is we can say that it's an extension of a linked list, we can say. Okay, but there is some difference is there, but it is in a linked list it is a linear, and here it is not linear, but there is a connection is there. In linked list, what is the there that it is a connected with the nodes. So here is also node, but there is a some specific condition or specific situations. If that is satisfied, then we can say that that is a tree. Okay, so here we can say that the no each round, for example here this are called nodes. That is what we written here, this node. Okay, and the 3 is the one node and 7 is the one node, and these 3 and 7 are connected by the edges. Okay, so only one edge are is there, correct? Only one edge is there, and this is only one, and there is no cyclic, which means the first node and the 2 and 3 are connected with the only one. Okay, and there should not be a connection between 2 to 3. If that case is there, then we can say this is a cyclic. Okay, so it should not be the case. So the as cyclic should not be there present in this graph. Okay, so what is then binary tree? Okay, a binary tree means there is, for a node there can be maximum two child nodes, which means, for example, here one is the node. Okay, and this one root node 1 has two child maximum. Okay, that is 2 and 3. So this 2 and 3 we are called as a child node. Okay, the child node 2 3 has one parent. Okay, that is the 1. Here we can see that the tree data structure started with the 1. There is no another node on top of the 1. Okay, so this particular node, node 1, will call as a root. Okay, so this is the definition. A binary tree in which node has maximum two child. The maximum it can have the node two child, or it can be less than that one. Either it may not be have the node, I mean it may not have the child. Okay, for example, the fourth node doesn't have any child. Okay, another one is 5, another one is 6, another node is 7. So these node doesn't have any child, so those nodes are called as leaf nodes. Those nodes are called as a leaf node. Okay, then as we can see here, there is, how many nodes are there? We can count from starting itself: 1 2 3 4 5 6 7, correct? Then in these 7 nodes connected with the how many edges? That is 1, 2, 3, 4, 5, 6. So we can form a formula such that if there is a n node is there, then n minus 1 edges will be there. That is what it is mean by this statement. If there is n node is there, there will be n minus 1 edges. Okay. Another terminology we used to hear that there can be, see for example, so we will started with the node 1. Okay, that node is called as a root. On the left hand side, there is a, again we can say that there is a one tree is there, correct? We can say that it is started with the 2, then its childs are 4 and 5. So this is a subtree of the parent one. So this subtree situated on left side of the node. So this is the bar. Okay, so this subtree called as a left subtree. That is called as a left subtree. Similarly, the right side also we have a subtree is situated. Okay, so each node will have this. Each node will have left hand subtrees on its parent. Okay, on its parent. For example, two's for example, two's left tree is the 4th and right subtree is the 5. Okay, so this is how we can say left right subtrees are there in the binary. So we need to familiar with. Then the another terms are we used to hear, that is the level. Okay, so what is mean by level? As we can see here, the node started with the 1 and it has two childs, that is 2 and 3, and this 3 2 has again, see, 4 and 5, and 3 has 6 and 7. Okay, so we can say that this is a level 0. This is a level 0, and this is a level 0, we can say, and 2 and 3 are level 1 nodes, and 4 5 6 7 are level 2 nodes. So level means each child's position, we can say that it's a level. Okay, then another terminology that is we used is the height. What is the height of the binary tree? The height of the binary tree is measured from the root to, from here to bottom. That is what is meant by the height is the path from longest path from the root to deepest child. Okay, for example, if this 5 has one more 5 has one more child called something 8, and again it has one more child. Okay, like that. So the height will be, what will be the height? The total path from root to till this. Okay, so that is called as a height. So height is the path that is starting from the root node to deepest node. Okay, then we also need to familiar with the tree traversal. There is a broadly we can divide the tree traversal into two, that is depth first and breadth first. Depth first means it is again further divided into three: pre-order, in-order, and post-order. So depth first means it will start from the node, then it will go depth. Okay, then it will first the visiting, I mean we can say that in linked list we also find that how do we traverse. So we will either iterate through the nodes, and then we will find the each element. Similarly, in order to visit each node, there can be different traversal are there. So depth first means it will start from the first, then it will go below uh, child, then it will go the 4, like that. So depending on the order of printing, it's again further categorized into pre-order, in order, and post order. Okay, so this is, we can say, depth wise it is traversing. So that's why this traversal is known as depth first traversal. And depending on the order of writing the value of each node, it is further categorized into pre-order, in order, and post order. Breadth first traversal is the level wise traversal. Means it will first print, I mean, it will first visit the node root, then the first level node. So the first level node, always the traversal is from the left to right in this direction. Okay, then the third level or second level uh, node traversal, so that is starting from the 4, 5, 6, 7. So that is why the breadth first traversal means. Okay, so these are the two widely used traversal. We can see individually each how we code and how we can implement in Java, but we need to familiar with this terminology, and in some in following videos we will cover each in individual video itself to code how it will be coding, coding, etc. Next tree is the binary search tree. So what is the binary search tree? A binary search tree is a comparative tree in which left subtrees always will be the left less than the value of its parent. Similarly, on right hand side, all the nodes will be greater than the its parent value. What it means is the 10 is the here, it's a root node, and 10's left, I mean 10's left nodes are 5, 4, 7. All are less than the 10, correct? And again there is a subtree is there. What is the subtree here? The subtree is again, it is starting with the 5, 5, and in this subtree, this is the no root, and its left side, its value is 5, and its left node is a 4, which is less than the 5, and 7 is the right hand side, which is greater than the 5. Okay, so this is how the binary search tree is um, I mean implementing. Okay, so these are the starting point, introduction to the tree data structure. Let's code one by one in the following videos. Thank you.
If you like the video, please click the like button and subscribe for more videos.